So let's now look at how the Valet Key Pattern extends this idea of securing your keys, securing your storage to your clients. So first, the metaphor. A Valet Key is a special key that comes with modern cars, and I'm from Boston. I have to work to say car instead of car. The Valet Key allows you to give the key to an untrusted third party, like the valet parking dude at the nice restaurant, and it allows them to access to certain functions of your car without full access to it. So, for example, a valet key can turn on the ignition and allow you to perhaps unlock the door, but it will not give you access to unlocking the trunk or the boot, depending on what part of the world you're from, and probably not the glove box or on the inside that might have other kinds of confidential stuff in it. So it allows you to control some aspects and give you enough confidence that you can give somebody your car to park without you worrying about them rummaging through private areas. So this is extended in a great way, in many, many ways, through the Valet Key Pattern as it's available through Windows Azure Blob storage. So I mentioned earlier that that you can, through a very simple configuration change, you can enable your blobs to be CDN enabled, but they had to be public blobs. So that's one valid kind of Valet Key Pattern as well, is that you can just make your blobs public, but that really doesn't give you any sort of granularity. So we could go back to the Cerebrata tool, and we could make a container like this. We can change its permissions. This one is public read access. So anybody can read this zip file out of this container if I give them the HTTP URL to it. We can also make changes to it. We can make the container private, or we can change the access so that so it's at the blob level, not the container level. And we can furthermore demo god's not with me today. You can furthermore update the permissions of individual blobs. All right, let me go back here. This is what I want to do. So you can make them public read only. That's easy to do. But any other scenario where if you want to make it writable, whether public or not, or listable, whether public or not, these are Valet Key Scenarios, and these require a different approach. The different approach allows you to do these kinds of things. I want to list the contents of a blob. This only has one in it, but if I want to give somebody the ability to iterate through them and look at them, I can do that with a Valet Key. I want to be able to read the ones that can in the blob container. I want to read a specific blob. I want to write to a container or update a specific blob or delete a specific blob. These are all kind of very focused permissions. I can give you a Valet Key. I can give him a Valet Key to write to a specific blob, and I can give her a Valet Key to write to a specific different blob. And his Valet Key will not work on her blob, and hers will not work on his blob. And these permissions available in the Valet Key can also have start times and end times, optionally. So I can give somebody permission to update a blob, but that permission expires at 5 o'clock in the evening. Server time, by the way. So this is not manipulatable by client-side code. This time is enforced on the server. So these are really, really powerful. Let's look at a couple of scenarios that that I've actually used this pattern with, and I actually used it 4 times. And then I said, "Wow, there's a nice pattern there," and this is there's a chapter on it in the cloud book. So I had a client that had an add-in to a desktop application, and they wished to beam a very large file into the cloud for extensive processing. This was a startup with a software as a service product that was used by building architects, and it was very clean to devise a mechanism where a very low complexity, low volume web service could issue these valet keys. So the add-in from the user's desktop would make a very quick call to a WCF service, and it would get back basically just a URL. And then with that URL, it was able to take its time uploading a very large file. And the uploading of that very large file did not negatively impact the performance of that WCF endpoint, because the blob storage capacity that we looked at when we looked at the scalability targets blog post was taking care of those needs. And the WCF service could be a very small instance with very, very humble scalability targets, because it's what it did was very surgical and very small. So it's very useful. Another one, I helped a genealogy site build some software that would allow users to look at images of genealogical data, but they were afraid that the site would be too easily crawled, and they didn't want somebody downloading their many, many terabytes of data, because it would be on their dime, right? If somebody downloads a terabyte of data from your storage account because you let them, you get to pay for that. So the opposite kind of Valet Key scenario was used, where they were given a read-only URL, and it had a time limit. And that worked very nicely and did a really good job of hampering the ability to do crawls because the blobs were never directly visible to the customers. Bandwidth savings. So the kind of with the architect add-in example I gave first, one of the benefits of this is the bandwidth savings. In another case that a client now has a situation where they are doing a lot of uploads in the middle of the night, and they want to really optimize the costs of that. And it looks now like we're able to do it on an extra small role instance, 2 cents an hour deal, where, because again, all the processing, all the upload power is handled by Azure Blob storage. So it would cost you the same from bandwidth point of view and storage transactions point of view if the blobs came through your web role, and then the web role wrote them to blob storage, versus going directly to blob storage. But the two disadvantages of that are that it adds a significant scale burden to your web roles. So in this case that I'm talking about here, they would have had to have much larger web roles to handle the load. But as it is, these are similar to the add-in case. They could be very tiny web roles that are just handing out valet keys, basically generating URLs and handing them out, and then it's up to the client to upload directly to blob storage. And the other, well, that's a pretty huge benefit. So I'm going to basically just wave my hand at the last one. There were also regulatory benefits. I've been talking to a customer with temperature sensors, and this can be used to help them guarantee their compliance, because they have to be able to prove that these that sensor data was not updated during certain times, and they can prove that with Valet Key signatures that are time bound. And this is just a little bit of a visual. You get, if you, instead of going to, so another one here is you can have the canonical photo upload from an iPhone, and you don't want to have to go through your web tier, and you want it to go directly to blob storage because it's more scalable. It's less costly because your web tier can be smaller relative to what you'd have to handle with this. And the reliability is better. The blobs, you take one of the middlemen out, and you let the blob robustness take over. Now, the mechanics of generating a valet key, I'm going to speed up here because we're almost out of time. It just uses the primary or secondary access key. There's no network call or anything. It's a cryptographic inline generation that basically you give it the parameters you want, read or write or list or delete or whatever, and then the start time and the end time if you want, and then you sign it with the key, and then it becomes valid, and that's checked on the server side. Now, just for the sake of expedience, there's also very quickly there's you can. So what I just talked about so far is a signature that once you send it out, you can't change it. But you can also create what are called access policies, and I think you're limited to it's either 3 or 5. I'm not remembering. But these are policies that have a name like overnight upload or contest, and then they have all the same parameters: a start date, an end date, read, write, delete, or list permissions, whatever you want. You can give them out signed to the name of the access policy. Then after they've been issued, you can go and change the access policy. And then, so basically you've influenced the effective permissions of everybody because of that. So that's a pretty cool way to manage it even after you've shipped them. I have a Valet Key Pattern code library in the works, and I'm working with a friend of mine who is more of a cross-platform guy, because you can do some of the same things on Amazon S3. They have some of the same capabilities in the storage. And also, as of the fall, Azure supports the same pattern for queues and tables, which is pretty cool. So you can do a shared access signature for, say, a queue, and a queue mechanism. So with that, I'm going to stop, and I think I'm going to turn it back to Brianna, and I'll let her finish up. We are going to give some book away.